Swayam Prabha. Digital India. Educated India.
Okay, let me continue with this art pressure, and this is obviously we are doing active art pressure, passive art pressure, and then how they are different from whatever we have learned at the very beginning, that effective stress at any depth. So, effective stress at any depth, if you know, then lateral art pressure at active condition or lateral art pressure at passive in passive condition, what way they are different. So, you have to find out the way we did at the beginning, effective stress, effective vertical stress, and then you multiply simply by active art pressure coefficient if it is active condition to get the active art pressure, and multiply by active art pressure coefficient, passive art pressure coefficient if you want to get passive art pressure. And how to get coefficient of active art pressure? If you know the value of phi, then Ka will be equal to 1 minus sin phi by 1 plus sin phi, and similarly if you know the phi value, Kp will be equal to Kp will be equal to 1 minus sin phi 1 plus sin phi by 1 minus sin phi. So, those are the things are known. So, you know the expression for active art pressure coefficient, passive art pressure coefficient, and we know the procedure how to find out the vertical effective stress at any point. So, if you know the vertical effective stress at any point, simply multiply by coefficient of art pressure at active art pressure if you want to get active art pressure at any point, or you multiply by a coefficient of passive art pressure if you want to find out the passive art pressure at any point. Okay, and this active art pressure coefficient and passive art pressure coefficient, they are known, that is Ka equal to 1 minus sin phi by 1 plus sin phi, or equal to tan square 45 degrees minus phi by 2, or similarly Kp equal to 1 plus sin phi by 1 minus sin phi, and corresponding this value also similar. So, these are the things already we have discussed, and how to find out the thrust behind the wall, some we have given, but so far we have not taken the problem will be taken later on. Now, so far whatever we have done, the Rankine's case we have considered, and that too we have considered level backfill. Rankine's theory means what? There is an assumption that there is no friction between the wall and the backfill, and the wall is vertical and there is a level surface backfill. But here now I will consider that the inclined backfill. So, cohesionless backfill and inclined surface. So, if you consider that, then cohesionless mass with sloping surface behind the smooth vertical returning wall. So, smooth vertical wall means still friction we are ignoring, vertical wall also we are considering, but only instead of if this is the wall, this is the earlier consideration, now the backfill is sloped with the angle some I suppose. The lateral stress acting on the vertical face of the element are parallel to the inclined surface. That means if I consider the element, so always this the pressure also will be parallel to this inclined surface. So, if I go any point along this, always direction of the pressure will be parallel to the inclined plane. And then thus any such planes experience not only normal but also shear stress. So, when there is a active case we have considered, at any point we have shown this and this. But now in this, when there is inclined surface on the element, not only this normal stress will be there, not only this normal stress will be there, there will be shear. So that means, needless to say, they are no longer principal plane. That means whatever plane we have got, or whatever plane we have got, they are actually principal plane. But now when you consider the inclined backfill, if I draw at an element at any depth, those element will not have principal plane, and on that plane normal and shear both will be there. The corresponding resultant pressure on the wall could be determined with the aid of Mohr circle. So, Mohr circle, I will show the next page. The magnitude of the vertical stress is depicted by the distance OC. I will show the experiment, and lateral stress acting parallel to the slope surface is represented by the distance OA, and hence sigma h equal to OA. OC and OA, what is this? I will show in this diagram. You can see initially whatever we have mentioned, that this element now I draw parallel to this and parallel to this and perpendicular to this element. If I draw on that element, these elements, this plane no longer principal plane, this plane no longer principal plane. As a result, on this there is a normal and there is a shear. What is the value that can be estimated? And this thing, first thing we have explained. And next thing, actually what I have mentioned, that Mohr circle, and of course failure planes will be still the same 45 degree plus 5 by 2 with respect to this. Earlier what we have done, it was like this, and failure plane was, this is the angle. Now this one is there and this one is there, so this is the angle. So this is the shown here. Now that we are talking about the Mohr circle, this is the Mohr circle. Normal case, horizontal, when it is a horizontal backfill, this is the Mohr circle. Okay, and now if there is a sloping surface is there at angle I, and you can draw a line through the origin to the angle I, and then it will intersect these 2 points of the circle. They will be representing actually vertical stress and lateral stress. So this is vertical stress and this is lateral stress, and this lateral stress OA actually is given, and I have shown the expression. And now taking this geometrically and considering this, we can establish the earth pressure coefficient at active condition or passive condition when there is a sloping surface. That means by drawing with the help of Mohr circle, we have already established what is the expression for coefficient of earth pressure for active case and coefficient of earth pressure for passive case. Similarly, when there is a sloping backfill, again we can take the help of Mohr circle and we can find out the expression for coefficient of earth pressure at sloping surface, coefficient of earth pressure active condition, and coefficient of earth pressure for passive condition. So that is the one. So this is actually when there is sloping backfill, this is actually your lateral stress, and this is actually vertical stress. Now taking this geometry, we can establish other things. You can see if I look back to that diagram, we can express OA by this geometrically, and again, and OC is nothing but gamma h cos I. OC is actually vertical stress at that point, gamma h cos I. So gamma h cos I actually was vertical here, but if I want to make it inclined, so that component will be with cos I. And then OB, if I go back to the diagram, OB equal to OD cos I, and R equal to OD sin I, and BD equal to OD sin I. So then AB equal to this. Okay, so these are the things all we can get from the geometry, and once we get this, and then substitute all in this way. So originally whatever expression I have written, that one I can substitute here, and then it will get this type of expression. and OD get cancelled everywhere, you can see. So it will become cos I by cos I, cos square I minus cos square phi, cos square I minus cos square phi into gamma H cos I. Okay, so this is the expression we are getting. So sigma H lateral pressure equal to OA equal to gamma H Ka. Okay, so gamma H was there, and then we have multiplied by Ka. So normally gamma H and Ka, that means Ka is expression is what? Ka is actually will be ultimately you can say this Ka is nothing but this cos I minus under root cos square I minus cos square phi, and cos I plus under root cos square I minus cos square phi. So this is actually your multiplied by cos I. So this is actually your coefficient of earth pressure for active condition when there is a sloping backfill, vertical wall but sloping backfill, then we get the Ka is this. So to find out the lateral pressure, what I have to do? I need to know I, that means slope angle phi, then I will get the Ka. Once you get the Ka, the value K, then I know the vertical stress gamma H. So gamma H into Ka will be there, and then they will be acting parallel to this. So I have to draw a line like this. So this is the way we have to do. So and then what is the thrust or total of this? So total actually you can see gamma HK. So you can draw like this diagram. Gamma HK. So half, this is half multiplied by gamma HK multiplied by H. So half gamma H square Ka. So Ka is nothing but this. You can see here Pa equal to half gamma H square Ka, or half gamma H square multiplied by this, and this is nothing but Ka. So this is actually we are getting when there is sloping surface. This is the active earth pressure coefficient expression. So this is little bigger expression because of the I, but interestingly, if you put I equal to 0 here, then definitely you will get the same expression of Ka equal to 1 minus sin phi by 1 plus sin phi. So you can put 0 here, this become 1, this become 1, and 1 minus cos square phi, that equal to sin square phi under root, that means sin. So 1 minus sin phi ho jayega come, then this will be again 1, this will be plus, and this will come again sin phi. So 1 plus sin, so this is again 1. So this is the case we are getting when the phi equal when there is a inclination, but in this expression if you put I equal to 0, you will get the same value. Similarly, for passive case also we can find out PP. Geometrically again we can do similarly and find out different components and then substitute and then the get expression, but I am not doing this because that is not very important for at this level. So what we need to know the active earth pressure coefficient or passive earth pressure coefficient by which we can do the design. Okay. So PP is also equal to similarly gamma H square Kp. So half gamma H square in multiplied by this expression, and this is nothing but Kp. And this Kp, you can see we have got a expression here again, and this Kp we have now additionally I and phi both are there, and if I put I equal to 0 again here, I equal to 0 here again, you will get this expression will reduce to 1 plus sin phi by 1 minus sin phi, which is actually Kp for level backfill. Okay. So this way you can do it. So that means we have got now Rankine's method by level surface. Now we have got inclined surface. both active pressure and passive earth pressure. Now we will look at some other thing, that is actually your, you can see this is actually Coulomb, sorry. We have assumed Rankine's theory, this is Coulomb theory. Actually, in Rankine's theory, before so far we have discussed Rankine's theory. Rankine's theory, actually there are set of assumptions. Assumptions are wall is vertical and there is no friction between the wall and the backfill, level backfill, all those things are there. But Coulomb's theory is a very much general. That means why very much general? You can see the wall need not be vertical. Most of the time in the actual retaining wall, particularly gravity retaining wall, it will never be vertical. It will be inclined. So inclined back face of the wall can be considered, and friction between the wall and the backfill also can be considered, and any slope of the backfill can be considered. So this is the generalized Coulomb theory. Based on Coulomb's theory, this is a generalized force diagram. Okay, what are the, this is the wall and what are the forces acting here, and based on that there are different forces, and then based on that we can draw the force polygon, and this is, suppose this is W actually, and this is actually PA. This is actually PA, is not written here. This is F and this is PA and this is W. Now based on this force polygon, the way we have done Rankine's theory initially, we can find out the PA in terms of this angle, different angles, and then this angle, for any angle we can we have drawn this, and then we can differentiate that active earth pressure with respect to the angle beta and set to 0 to find out the angle at which it become optimum. So all those things process can be done, but they are very lengthy steps, and I just not do that. So that is the procedure. That means similar way, the way we have done for Rankine's case, based on force polygon, we express the PA in terms of angle theta, beta, phi, delta, alpha, all those things. And here actually the failure plane is important. The failure plane angle is here actually alpha, and this alpha will be changing. So alpha can be optimized. For a particular value of alpha, we can find out what is the value of active earth pressure. So that way, if we do, and then finally we will end up with a value. You can see now, next slide. You can see that we will get a expression for PA equal to half gamma H square equal to cosec beta sine beta minus phi under root this and this whole square equal to half gamma H square K. So now what is delta? That is angle between the because of the friction, the backfill and the wall, because of that delta, and beta is the angle from the backfill inclination. So if this is a backfill is like this inclined, then in that backfill this surface of the wall, and this is not 90 degrees. So what is the angle from horizontal? It can be 90 degrees or it can be more than 90 degrees. That is shown here perhaps in the previous diagram. I will show you once again. You can see beta is shown from here to here. Okay, and phi is the angle of, and the delta is the friction between the backfill and the wall, and I is the inclination of the backfill, and all those things you can see. With based on that, we have got a expression for PA and now half gamma is square is a normal vertical, it is a half gamma is square. This is actually area of this equal to half gamma is square. And to find out, so if I this one express this form, then there is a I can express this one by K. So K ultimately become this K is nothing but this expression. So this expression is this K equal to entire bracket portion. Okay. So similarly, PP also can be obtained, half gamma square multiplied by this. Only you can see it was plus here, it is minus, everything is same. Like previously you have got active art, passive art pressure, it will be inverse only, K equal to 1 by Kp, similar thing here also. So now this Kp, so here actually Kp will be equal to entire expression in the bracket. So this is a very generalized expression, and this expression little lengthy, but it is a function of all angle of the wall face and the angle of internal friction and the friction angle between the backfill and the wall face and the backfill inclination. And so this Coulomb's law, Coulomb's theory actually, though the expression a little lengthy, but since it is a more practical, that means all possible difficulties or possibilities in the field we experience, all are considered. That means friction between the backfill and surface is considered, the backfill can be inclined, that is considered, wall face can be inclined, that is considered. So these three additional things actually considered here. So because of that, this is more actually actual to the or close to the practice. However, most of the time, because of this lengthy nature of the expression, people do not use this. Most of the time, people prefer to use the Rankine's theory. Okay, and by this process, actually, when we calculate the value based on Rankine's theory and by Coulomb's theory, we get a difference approximately 10 to 15%. So sometimes to take that effect in consideration or in the design, sometimes they can use the Rankine's theory, and the pressure will be reduced by 10 to 15%. Actually, more accurate value we get from the Coulomb's theory, that is lesser value we get, whereas in Rankine's theory we get more value. So to knowing this fact, to make the design more appropriate, people use Rankine's theory with some reduction, 10 to 15% reduction. Otherwise, one can do directly using Coulomb's theory. So these are actually by and large various aspects of art pressure calculation, and we need to know. Next, actually, we have I just show one or two things. That is, suppose we have, as I have mentioned, that Rankine's theory and Coulomb's theory. Rankine's theory, suppose this is one wall, and backfill is something like this. Though some modification we do in calculation, what modification we do? Though wall height is this is h, and but in by Rankine's theory we do calculation. What we do generally? We do a imaginary line from here extend intersecting this, okay, and then we consider this as a wall height. We consider this as the height of the wall, and then we calculate Ka or Kp, and then we find out active earth pressure PA or PP, and then we apply those here. This is H and this is suppose H dash. So ultimately we will apply PA, suppose somewhere here PA, and this height will be equal to H dash by 3, not H by 3. So this is the simple modification we do while this type of problem will be there. In the calculation we do this type of modification can be done. Similarly, if there is a wall something like this, and accurate, then what will be the height of this? Okay. So this height, this H dash will be H plus, H dash will be H plus, and if this angle is I, and then this, if you know this distance, then you can find out this. Okay. So plus something. So suppose it is tan I. So this x by h tan I. So h equal to x. This is, if it is x, this is tan I. So x will be so x will be x will be h tan I. So this will be h plus so this is, suppose this distance is x and this distance is h. So h by x equal to tan I. So I need to find out h equal to x tan I. So if I know this distance from this edge to this, so this will be h plus x tan I. So x is here mentioned. So that means h dash will be modified, and based on that I can calculate PA and PP, and then point of application will be 1/3 height from this. Similarly, the wall, gravity retaining wall, sometimes like this. In that case, how to do this? Though this, for this case Coulomb theory is more applicable. So instead of using Coulomb's theory, what we can do? We can do the vertical line from here. We can draw a vertical line from here, and then whatever height was here, h, and this height can be obtained h dash, and then the force what resultant PA or PP can be applied like this from h dash by 3 distance. And here additionally what you have to do while doing analysis, this weight has to be taken, here also this weight has to be taken. So when you do the stability analysis and all, which actually is not in this course, here actually our job is to find out only the pressure or thrust, but when you do the stability analysis, you have to do this type of modification. While doing this modification, when you are imagining the wall is here, then the weight of this concrete, weight of this soil, all will be to be considered. So this we have to consider. Similarly, when you consider this one, weight of this wall will be considered, again weight of this portion also will be considered for the stability analysis. So but stability analysis out of the scope of this course, so we will not discuss that. Only we will show how to find out active earth pressure, passive earth pressure by different methods. Okay. So this much here, and let me stop here and let me proceed for next. Thank you.